Hello everyone and welcome back to Nunley Math. Thank you so much for joining us here today as we spend just a few minutes talking about the volume of prisms and cylinders. The volume of prisms and cylinders. We're actually going to do this as a series of videos. One today where we introduce the idea of what volume is and we use some simple rectangular prisms to help us with that. Then we're going to spend a day talking about triangular prisms, a day talking about cylinders, and then we're actually going to take a couple videos and talk about how that applies to cones, pyramids, and spheres. So this should be a really interesting series of videos. I think you're going to find that these videos are a little shorter than some of the ones that we've done in other lessons, and I think you'll probably appreciate that. I'm trying to split this up over several days to make sure that my students get lots and lots of practice doing each type. So let's go ahead and get started. In order for us to talk about volume, it's first important to remind us of the difference between area and volume. So for example, if I have a two-dimensional shape like this rectangle down here, I might ask you, how much space does this rectangle take up? Well, it's usually easiest if we figure that out by trying to fill it with squares. In this case, I'm using a square inch. It's called a square inch because it is a square that measures 1 inch in one direction, 1 inch in a second direction. So we're measuring the insides of two-dimensional figures. Now, probably you can use the square inch that I gave you, and you can pause the video and estimate how many square inches large you think this rectangle happens to be. I'm going to assume that if you wanted to do that, you will have already done it, and I'm going to keep right on going. Well, let's see. If I were to fill this with squares, you can see that this is 6 inches long. Notice I can use my squares to measure one dimension as well without paying attention to the second dimension, but then I can use that second dimension to find how wide this rectangle is. It's 4 inches tall. Now, if you're a middle school student, you can probably look at that now and you can probably calculate how many squares it would take to fill this object simply by looking at this as an array. Notice that we have 4 rows of 6 squares, 4 rows of 6, or you could say we have 6 columns of 4 squares. Either way, it's going to take 24 1 inch by 1 inch squares or 24 square inches to cover this shape. Now, you probably learned a formula in elementary school that says use the length times the width to get the area of a rectangle, and you could come up with 24 that way as well. In fact, that's how we derive the formula for the area of a rectangle. Now, let's say I want to talk about volume though. Volume deals with three-dimensional shapes, so I have to measure volume by using cubes. Notice that now I am measuring 1 inch not just tall and wide, but also 1 inch deep. Now, these dimensions are kind of interchangeable. I could call this the length and call this the width and call this the height. If I wanted to think of this as laying on its side, it really doesn't matter which one's length, width, and height. The important thing is that we're measuring all three at the same time. And I can take these inch cubes and I can use maybe 6 of them long and 4 of them tall, and I can actually build not just a rectangle, but a rectangular prism. That's a three-dimensional object that has a rectangular base that is the same both on the top and the bottom, or you could say the front and the back in this case. Notice that now I have not a two-dimensional figure, but a three-dimensional figure that's made of 24 1 inch by 1 inch cubes. Here again, I have not just a length and a width, but I also have a height. Again, notice I used height here and height here because we're kind of looking at it from different perspectives. We could change one of those to width if that made it less confusing. Does that make sense? Here again, our length times width formula still holds. It's still 24, but now it's 24 cubes instead of 24 squares. So if I come over here and I say how much space does this rectangular prism take up, we know it's 24. But what if I were to add a second rectangular prism, a red rectangular prism, to the front of the one I already have? How many cubes would it take to build this entire object? Well, we learned that the blue prism was 24 cubes, and we've just duplicated that here again. We've done 24 more cubes, so we know that this figure is going to require 48 inch cubes because I just took the 24 and I doubled it, or I took the length and the width and I doubled it. But suppose I were to add a third prism made of 24 cubes. What would it take to build this object? Well, I know each of my figures, or each of my prisms, is 24. If I put 3 of them together, it's going to be 24 times 3. It's going to take me 72 1-inch by 1-inch by 1-inch cubes. I take that 24 from the original prism and I triple it. And I could continue this on and on. I could add a purple one. That's 4 sets of 24 for 96. Or I could even add a yellow one. That's 5 sets of 24 for 120. 24 times 5. Or I find the area of the first prism, and then I just see how many of them are stacked together. You see, that's the idea behind the volume of any prism or cylinder. It's this idea that if you can figure out how many cubes it takes to build the first layer, then all you have to do is stack those layers on top of each other and count how many stacks you have. In the case of a rectangular prism, the base is a rectangle, so it's going to be length times width times height. And sometimes we write this as the formula area of the base times the height, or volume equals length times width times height. You're probably already familiar with this formula. So that when I give you a figure that looks like this, we know we need to figure out how big the base is. It's 25 by 8. 25 by 8, or the base is 200 cubic centimeters. That's if it was only one tall. But I'm going to have 3 layers of 200 for a total of 600 cubic centimeters. Over here, my base is 12 by 10. It's going to take 120 cubes to build this first layer. But this shows me that I'm going to be 7 layers tall. So I'm going to have 7 120s for a total of 840 cubic inches. Now, some of you might be saying, well, in this particular example, my length and width were up and down and right and left. You could do this as 25 times 3 and get 75 and do 8 layers deep. You could do this as 3 times 8 and make this side the base and have 25 layers of 24. It really doesn't matter which one is your length and width and the height, because in a prism, no matter which side you pick to be your base, you're always going to be stacking up. Remember, the commutative property says the order of these numbers does not matter. Again, that's going to be it for today. I am going to split this into several shorter videos. Make sure that you check out the others, because we're going to use this idea of stacks or layers to look at some more interesting figures in the coming days. Thank you so much for joining us here today. You guys take care of yourselves, all right? Bye-bye.